So welcome back and welcome to video 22 in my series on AnyRail. This time I want to talk about passing sidings. Now you might consider this video a throwaway video. It may not be very helpful. Then again, it might be. I learned quite a few things though while I was putting together all of the examples, and I thought I'd share that with you. Now this video started when I was working on another video on pre-built entities. And I got to my pre-built entities that showed passing sidings. And I looked at what I already had and I said, well, they're nice, but I wonder if I could make them a little more accurate. I was also thinking about how much space does the transition track from the diverging point on your turnout to the passing siding take up? And where exactly is the fouling point? How far can you bring your locomotive or leave the end of the train to the track and still have clearance for the train passing on the main line? So I was thinking, well, there must be some kind of information somewhere on the web. I had already gone through all the books I had and couldn't find anything on fouling points. So I went online, did a lot of searching, and all I could find on fouling points was a definition of what a fouling point is. Nothing about how to determine where that point is. A friend of mine suggested that the fouling point might be somewhere near where two people riding on two different trains that are passing each other would actually collide. And that sort of makes sense. And it also makes sense that it would be the point where the equipment on the passing siding, how close it could get to that main line. But I couldn't find anything. I did find one thing from CSX Railroad from a university. And they had a description of turnouts leading into a passing siding, and there was a point that they called the point of tangency for the passing siding track. So I thought, well, I'm going to work with that point of tangency. Now here's basically what I want to do. Let's grab a switch, and let's take that switch and we'll place it precisely on a grid point. So let me do that. Okay, there it is. And I'm doing this because I want to be able to check precisely the spacing of my tracks between my main line and my passing siding. So now let's add the track that would be our main line. And we'll just connect it up here. Now, ideally, what I would like to be able to do is I would like to be able to go and grab a piece of track that has a predetermined radius and just attach it here to the diverging track and have that piece of track already made up. So when I put it in, my passing siding is say 2 inches or 2.5 inches or whatever you want to use on your railroad. So after a lot of playing around, I sort of came up with this drawing here. Now this is for number 6 turnouts, and these are Walther's turnouts, code 83 turnouts, and it's going to be different for whatever turnout you use, so which means you're going to have to make one of these if you want to do something like I did. But what I did is I just played around with different track spacing and where I could put that point of tangency. Let's zoom in a little bit here. So here's the point of tangency. And as you can see, I used 18-inch radius just as an example, but I came down here and I started working with radius track here that I would be using on my railroad. And I came up with 24 inches for these two right here, because that's the minimum radius on my railroad. And then I did it with 28-inch radius just to make the curve a little bit smoother. On all of these examples, I used smooth flex. So here's basically what I would like to be able to do when I'm designing. I would just like to be able to go to my pre-built entities track, come up here, select that piece of track, copy it, come back here, paste it in, connect it, get myself another piece of track, connect it there. There's my passing siding. Now if we zoom in on it, I want 2-inch spacing on my main line. So if we look here, look up above, we can see the Y is 24 inches. And we come down here, look at that, we see the Y is 26 inches. And this curve has a minimum radius of 24 and 1/64 inch. And since I'm using smooth flex, this is actually a spiral easement, and we've gone over that in the 2 videos on easements. So that's pretty cool. That means as I'm building my railroad, designing my railroad, I can use either 24-inch or 28-inch coming off the diverging track. Now let me get sidetracked here for a little bit. What would be really nice is if I could take this piece of track here, let's paste it back in. If I could take this piece of track, pre-built, give it a name, and put it over here. Or if there's a way that I could build up another window like this that just has all my pre-built entities in it. That way I wouldn't have to have another drawing open and go grab it from there. I could just have it all over here. So that would actually make a nice addition to AnyRail as far as I'm concerned. But like I said, I'm getting a little sidetracked here. Now let me go back to that other drawing real fast. And I just want to show you a couple of things about this real fast. And then I'm going to go back and I'm going to show you how I actually determined what this piece of track should be. So here I have a number 6 right-hand turnout. Now this works with number 4s, 6s, 8s, number 5s. And I have a chart showing the exact same information for each size turnout available on my website. And there's a link in the description there if you want to go get it. So here's our number 6 right-hand turnout, and I started with figuring out the diverging track end angle, this point right here. And that turns out on a number 6 Walther's switch to be 260.47 degrees. So then I just figured out what amount of curvature I needed to get it to go horizontal, or 270 degrees, and that turns out to be 9.53 degrees. So here's 2-inch spacing between these tracks. Here's the point of tangency. And then this starts our spiral curve here into the diverging track. Now, one of the things I was concerned about, because, room is at a premium on a model railroad, is what is this distance from here to here? The longer this distance is, the less passing siding you have. So that's what this measurement here is showing. It's showing from the end of the diverging track to the point of tangency. It takes up 6 31/64 inches. And then over here, I have what that equals in the real world. In the real world, 6 31/64 inches is equal to 47 feet. Now, this line here says curve equals 6 33/64 long by 24-inch minimum radius. Now, if I hover over this piece of track here, and you look down below, it says the minimum radius is 24 1/64, and the flex is 6 33/64. But that just kind of shows you how far the distance is here. Now, if you come down here and you look at 2.5-inch track spacing, you'll notice that that distance increases to 9 13/32. So that's starting to eat up quite a bit of space on your railroad. If we come down even farther, it eats up a little bit more with 28-inch radius. Not much, but just a little bit more. So that's what my charts are showing you. They're showing you what the distance is to the point of tangency. And that kind of gives you an idea of how much space you're going to eat up on your railroad when you put in these curved tracks. So let me show you how I came up with this track right here, and then how you can do it for your design using whatever brand of turnouts that you're using. So let's start with this guy here, and then I'll show you a kind of a pitfall that I discovered with this method that I use to determine the radius for that track on the diverging track of the switch. So this is something like you would encounter, and you would have your switch here, and you have your main line track here, and you want to put in a passing siding. So the easiest way to do that, and we've gone over this before, but we'll show you again, is just do add parallel flex. So in this case, I want it to be 2 inches away, and I want it to be below the main line. So I'll just hit OK. So now we have the beginning of the passing siding. So what I've been doing is I've just been coming up here and I've been guessing. I've been saying, oh, I think I'll cut that flex somewhere right around here. So now I've got a cut point. And I can check and make sure that it's exactly 2 inches by just clicking on that connection point. And if you look up above, the Y now says 26. We started at 24. This is the 24 mark. This is 26. So now let's just grab this end and connect it. Now we'll select this piece and we'll say smooth flex. And let's see what we got. Well, that's actually a pretty good start. We've got a curve here of 25 and 49/64 minimum radius. Now, I could stop right there if I wanted to. I mean, I don't really need to go any farther than that. I've got this nice piece here. I could copy this piece, flip it around. I could bring it over here. I could get another number 6 switch. And we'll flip that one as well. Oops, try it that way. We'll attach it like that. We'll pull this guy back. We'll attach that, bring this over, attach it. We now have a passing siding. I could take this piece of track and I could copy it and I could put it into my pre-built entities drawing and I would always have it. But let's say you're shooting for a specific radius, or you want to massage this track a little bit. You want to make the radius a little bit larger, or you want to make it a little bit smaller. So let's see how we do that. Let me reset this drawing. Okay, now we're back to where we were. And if we hover over this, we see the radius down there, the minimum radius. Now what I can do here is I'm going to zoom in. I don't need to see the whole thing. I'm going to come over here, I'm going to select this point like that. Then I'm going to come up here and I'm going to select Move Connection. And now I can move just this connection. I can move it vertically if I want, but that wouldn't make any sense. But I can move it horizontally. So right now it's at 30 and 5/8 inches. So let's see what happens if we go to 30 and 3/4, which would be 30 and 6/8. And you'll notice down here, this moved over. Now, I come back here, I select this guy, I hit smooth flex again. I always have to hit smooth flex after I move the point. And now what do we have? Now we have 27 and 23/64. So as you can see, I can move this point back and forth and I'll get a different radius out of this easement track right here. Now let's move it the other way. Let's go down to 30 inches. Now remember, this track is 27 and 23/64. So let's go to 30 inches up here. We'll smooth it again. And you'll notice I moved 3/4 of an inch, but I went down to 18, well, just about 19-inch radius. So you don't have to move this point very far to get big changes in the radius. So let's try one more example here. I like to work in decimal when I'm doing this. So I'll do something like I'll put in 30.55 and then hit enter. And then I let AnyRail convert it to a fraction up there, because for some reason it just makes more sense to me to work in decimal than trying to go 30 and 34/64. It's also a little easier to type. So let's see what we got now. So see, I moved this point 5 inches and we went from a minimum radius of, let's see what it was, 18 and 63/64 to 19 and 11/32. So we had 30.55 before, so let's go 30.63 and see what we get. I know I'm belaboring the point here, but I just want to see what we get. Now we've got 25 and 53/64. So in order to get a 24-inch radius like I would want to make, I want to set it to my minimum radius, I'd have to move it somewhere between 30.63 and 30.55. It's getting better. It's moving down towards 25 and 2964. So that's what I did when I made up those charts. I just kept moving this in small increments and then hitting smooth flex again and seeing what I got until I got the track that I wanted. Okay, now you can run into a problem, and I'm going to see if I can duplicate it here. I'm going to move the point to the left, which will make it for a sharper radius. So I'm going to come over here and I'm going to say, let's go to 29.5. Let's see what happens. All right, first thing you'll notice is that I've got the red mark here saying I'm below my minimum radius that I've set. My minimum radius is 18, so this is below 18. But let's see if I can show you here. Yeah, okay, this is going to work. It's kind of subtle, but I've developed an S-curve here. The track kind of does this. I don't know if you can see it, but it kind of does that on the bottom. Let's go in a little bit tighter. Let's move this over a little bit more. Let's take that to 29. Let's smooth it out. And you can see kind of a little bit of an S-curve here. Now, I have also run into problems by moving this point farther out. And I'm not sure if it's going to do it here on this example. I'll show you on one of my pre-made sheets an example of putting in an S-curve. So that's one of the things you got to look out for when you use this method, is you got to look and just make sure that, you know, it looks like it's going to be okay. Sometimes you can go to center line and zoom in, and you'll notice that it just looks funny right here. That's because this handle, there we go. Can you see that gray in the middle? Notice how the gray over here is in the middle, but over here it's going towards the top. That's part of the S-curve right there. So that's something to look out for when you're using this method. So that's a good way to build up the track going into your passing siding. And of course, you can do anything you want here. I can set this to any size that I want, meaning, you know, the distance between the tracks. I could say I want 2.25 inches. And then just do the same thing. Select a point. Let's select a point out here. We'll cut it right there. We'll drag that up. Hit smooth. What do we got? Nice gentle curve coming in. And I can zoom in, and I don't see any evidence of an S-curve doing that. Usually I run into the S-curve problem when I have a smaller turnout number and I'm trying to put in a larger radius, and I'll show you that on one of the other drawings. And you'll notice that while this 64-inch radius curve coming into the passing siding looks really nice, we've taken up a little bit over 11 inches. So that's eating up 11 inches of your space there. And that's why I pretty much started this whole thing and this whole video, is because I wanted to be able to push this point as close as I can here and still maintain a nice radius in my track. And then that way I get the most passing siding room that I can achieve with, you know, that minimum radius. Okay, let me show you an example of an S-curve on another drawing. Okay, here's a number 8 turnout siding spacing for various radius curves. That's a very nice title to this drawing. And up here, for some reason, I always started with 18-inch radius. Don't ask me why, I just started with 18-inch radius. And as you can see, with 2-inch track spacing and an 18-inch radius curve, there's a very obvious S-curve in there. And this guy here is actually mislabeled. That should read 2.5-inch track spacing. I have it right here. I don't have it right here. I'll correct that before I put it up on the website. And again, you'll see I've got that S-curve in it. Now, coming down here, I've got a 24-inch. And if you look at it closely, it's got it looks like it might have a minor S-curve in it. Let's take a look at that a little closer here. And yeah, it kind of does look like it has a little S-curve in it. This gray line looks a little closer here at the connection point than it does down here at the handle. And yeah, I can see a little swoopy line here. So yeah, it's stuff you have to be, you have to look for. Let's look at another one. Here's the number 5 turnout sheet. And again, I didn't mark it, but that kind of looks like it's got a little bit of an S-curve in it. And that's an 18-inch radius going to 2.5 inches. I haven't found any rhyme or reason as to, your track spacing versus where this point is. It just seems to come up randomly. So when I was making my charts, I just very carefully looked and made sure that I didn't have any S-curves in any of the pieces of the track that I wanted to use. Okay, so these are going to be up on my website, and there'll be a link down below if you want to download them, one or two, just to take a look at what I did here. But if you're going to build something like this for, say, a pre-built entities drawing or just in your regular drawing, you're going to have to do your own figuring out where these points are, because you'll probably be using different track components than I am. And this is only for the Walther's Code 83. Now, I wish there was a way I could put up some of these pre-built entities, but I don't know how to put them up there and make them safe for you. And probably, if you're like me, you wouldn't want to download them anyway, because you never know what you're going to get from the web. Now, one other thing I want to point out before we go is somebody might say, well, look, I could take this measurement and I could build up these two pieces of track with the switch. And I could take that measurement and I could cut this piece back 5 55/64 of an inch. Then I'd get my cut point and then just drag it up, hit smooth flex, and I've got my piece of track leading into my passing siding. And that's what I thought at first. I thought, yeah, you could probably do it that way. So I experimented with it. And I don't understand why, but when I do it that way, the track doesn't always come out the same. I get different minimum radiuses each time I try it. Is it something I'm doing wrong? I don't know. Is it something in the way that AnyRail calculates it? I don't know. So my idea is I'm just, going to use my little charts here. I'm going to take the pieces that I want and I'm just going to put that into my pre-built entity drawing, and I'm just going to go with it that way. And once again, I'd like to point out, and this is for the creators of AnyRail, that, man, it would be really nice if we could take track components like this. Say, take this switch and this piece of track right here, and then turn them into an entity that we could drop in to the pre-built components over here window, or create another window. If there is a way to do that, please let me know, but I can't find a way to do that. But man, that would be handy, because then you would have all of your stuff right there. Any fancy little piece of track work that you built would be right there and always available to you. And I think that would be a really, really nice feature in AnyRail if you could do something like that. So let's end this video. And like I said, I think this is kind of a throwaway video. I mean, I'm showing you stuff that you probably already know, but it's one of those things that I just got curious about. And I said, well, let's see what happens if you try this or you try that, and how that could work and then be put into my pre-built entities drawing. And then that way I know I'm accurate on my distances here. I know I'm always going to get 2.5 inches or 2-inch spacing using these pieces of track. If there's anything in here that I didn't cover and you think I should, please let me know and I'll just redo the video and we'll include that. But I think I got all of the points in that I wanted to talk about. So we'll see you in the next video.